Hello, I saw video 12, it's horrifying. James Webb just scanned Europa for the first time. James Webb just scanned Europa for the first time. Discover the terrifying and mesmerizing secrets of Europa like never before. In this video, we reveal what the James Webb Space Telescope uncovered on Jupiter's icy moon, fresh chemical deposits, a hidden ocean, and signs that Europa might be alive in a chemical sense. If you've ever wondered what lies beneath miles of frozen ice, this video is your gateway to one of the most dynamic and mysterious worlds in our solar system. We dive deep into Europa's chaos terrains, the hidden subsurface ocean, hydrothermal vents, and the chemical fingerprints Webb detected: sodium chloride, carbon compounds, and hydrogen peroxide. Learn how tidal heating, ice shell fractures, and ocean convection create a dynamic environment potentially capable of sustaining life. This video is both educational and immersive, designed to help you understand the latest discoveries in planetary science, astrobiology, and space exploration while experiencing the wonder of one of the solar system's most intriguing moons. If you enjoy exploring the universe and uncovering hidden cosmic mysteries, give this video a like, share it with fellow space enthusiasts, and subscribe to the channel for more deep dives into alien worlds and hidden oceans. Your support helps more curious minds discover these fascinating stories and expand their understanding of the universe. Hello there and welcome to this Discover the Universe Before Sleep, your destination for captivating explorations of space, planetary science, and cosmic mysteries. In this channel, we blend storytelling, scientific insight, and relaxing narration to help you unwind while learning about the universe in an engaging, thought-provoking way. Note: this video uses AI-generated content for illustration, narration guidance, and educational purposes to help viewers understand complex scientific concepts more vividly. It is intended for informative and educational use only. Europa Exploration James Webb Telescope Hidden Oceans Chapter 1. The first horrifying glimpse of Europa. Have you ever imagined staring at a moon so cold, so distant, and so alien that every instinct in you tells you it's lifeless, yet discovering, in a heartbeat, that it might not beat? That's exactly what happened when the James Webb Space Telescope turned its infrared eyes on Europa for the first time. And the results were horrifying. Not horrifying like a jump scare, but horrifying in a way that shakes everything you thought you knew about our solar system. If you've ever lain awake at night, staring at the stars, wondering if there's life beyond Earth, this story is for you. Because tonight, you're not just an observer, you are a witness to history. In the next few minutes, you will discover secrets hidden beneath miles of ice, secrets that have remained untouched for 5 billion years, and that could rewrite what we understand about habitable worlds. James Webb, orbiting 1 million miles from Earth, focused its golden, tennis court-sized mirror on Europa, Jupiter's enigmatic moon. This tiny, frozen world has long been suspected to harbor a subsurface ocean, but until now, no telescope had revealed what's truly happening beneath its icy shell. In mere minutes of observation, Webb detected chemical fingerprints that should not exist on the surface: salt and carbon compounds, freshly exposed, hinting at a dynamic, living ocean below. Why should this matter to you? Because these aren't just abstract facts, they're a glimpse into a world that might be alive, quietly reshaping itself under the harshest conditions in the solar system. Every piece of data Webb collected is a whisper from a hidden ocean, a message that Europa is more than a frozen wasteland. It's a laboratory, running experiments that Earth has never witnessed. Before we dive deeper, take a slow breath. Let this curiosity settle in your mind. If you feel a spark of wonder or even a slight chill, consider pressing the like button. It helps this story reach others who, like you, are seeking awe, curiosity, and perhaps a little sense of cosmic calm before sleep. Over the next few minutes, we'll explore what Webb saw, why scientists are calling it horrifying, and what it tells us about the ocean beneath Europa's ice. You'll learn about the strange chemistry concentrated in a chaotic region called tidal, about carbon and salts rising from below, about hydrogen peroxide forming in unexpected places, and about a system that is alive in the geological sense. We'll also discuss why this discovery raises questions that humanity has never faced before. Could life exist there? How do we even begin to explore it? And what does this mean for our understanding of life in the universe? By the end of this journey, you won't just understand the science, you'll feel it. You'll feel the tension of an untouched world slowly revealing its secrets, the wonder of a hidden ocean larger than all of Earth combined, and the subtle horror of realizing that for billions of years, this life, or chemistry that mimics it, has been entirely unknown to us. So, let your mind drift as we move closer to Europa. Picture standing on the frozen surface, Jupiter looming above, ice stretching endlessly beneath your feet, and a hidden ocean whispering secrets just beneath. This is not just astronomy, this is a story written in infrared light, a story that Webb has begun to tell, and one that humanity is only now learning to read. Chapter 2, Europa's Chaos Terrain. A window into a hidden ocean. Europa is not a quiet, frozen wasteland as we once imagined. Beneath its pale icy crust lies a world of constant motion, a chaotic ballet that has been playing for billions of years. And James Webb has just given us a first glimpse into it. Imagine a surface broken, cracked, and rearranged in patterns that make the moon look like a shattered mirror reflecting Jupiter's light. This is Terra Io, a region scientists call chaos terrain. Here, the ice isn't merely sitting still, it is actively shifting, ray freezing, and revealing secrets from the ocean below ocean below ocean below ocean. Webb's infrared sensors picked up something that would have been impossible to see with Hubble or any visible light telescope. Chemical signatures that should have been destroyed instantly by Jupiter's intense radiation. Sodium chloride, the same compound we sprinkle on our food, appears pooled in these broken patches of ice, and right on top of it, carbon dioxide. These chemicals, fresh and concentrated, act like a neon sign flashing something below is alive, at least chemically. The surface tells a story, but it's not a story of destruction. It's a story of exchange, of dialogue between the hidden ocean and the icy crust above. Picture cracks forming as warm water or slushy ice rises from the depths, ray freezing and leaving behind a chemical fingerprint. Webb saw this happening in real time in the span of minutes, capturing the ongoing conversation between ocean and ice. And the more you imagine it, the more it becomes personal. This is a world that, just like you, is alive in its own way, sending messages from a place you cannot reach, from an ocean that has never known light. The high concentrations of hydrogen peroxide detected in unexpected equatorial regions add another layer to the mystery. On Earth, oxidants like this are essential for life, storing chemical energy. On Europa, they form in combination with carbon dioxide and salts, creating pockets of potential energy in a frozen oceanic landscape. What Webb revealed is a world, not just habitable, but chemically active, a place where the ingredients for life could be continuously supplied and redistributed. As you imagine standing on that broken ice, feeling the cold seep into your bones, think of the ocean miles below, teeming with potential energy and chemical reactions, hidden from the eye, but now whispering its presence through the ice. Each crack, each chaotic patch, is a pathway, a bridge connecting what we can see to what has been hidden for eons. Over the next few minutes, we will explore how these chaos regions might allow Europa Clipper, set to arrive in 2030, to sample ocean material without drilling through miles of ice. We'll examine why the arrangement of salts and carbon is not random, how the chemistry hints at hydrothermal activity deep below, and why this discovery is rewriting the models of ocean worlds. Let your mind settle into the rhythm of the frozen cracks, the subtle energy exchanges, and the quiet chemical storms beneath the surface. This is Europa speaking, through the language of ice and chemistry, inviting you to witness its secret life before sleep. Chapter 3. The dynamic ocean beneath Europa. Beneath the fractured ice of Europa, there is an ocean unlike any we have ever known. An ocean larger than all of Earth's combined, swirling silently under miles of ice, dark and cold yet full of hidden energy. James Webb's observations give us the first chemical evidence that this ocean is not stagnant. Salts and carbon compounds rising to the surface tell a story of movement, of convection, of a world quietly alive in a way humans are only beginning to comprehend. Imagine a vast, hidden sea, 40 times deeper than our oceans, its currents pushing nutrients, minerals, and perhaps more exotic chemistry upward through tiny cracks in the ice. The presence of freshly deposited sodium chloride and carbon dioxide in chaos regions like Terra Reio is a clear fingerprint. The ocean below is actively interacting with the surface, and this interaction is recent, happening over geological yesterday, not eons ago. These chemical pathways suggest a system capable of redistributing energy and matter, creating microenvironments that, on Earth, might support life. Hydrogen peroxide accumulates in the same regions, providing a potential energy source for any microorganisms that could exist beneath the ice. Consider what this means. The upper ice is a chemistry factory powered by Jupiter's radiation, while the ocean below is a reactor, mixing salts, carbon, and heat from tidal forces. Together, they form a continuous exchange, a cycle that maintains dynamic equilibrium. This is not merely an academic insight, it is a visual revelation. Europa's ocean is alive chemically, feeding the surface with signals that Webb can read, that we can imagine, but that no human has ever physically touched. The ice above is both a shield and a medium, preserving evidence or revealing hints of processes millions of years in the making. Every fracture in the chaos terrain is a conduit, every salt patch a signature of deep water activity, every carbon molecule a potential clue about the chemistry of life itself. As you listen and let your imagination drift, picture the dark ocean currents, moving silently, bringing chemical whispers to the frozen lid above, creating a subtle yet persistent heartbeat beneath the ice. This chapter of Europa's story shows us that a world previously thought dormant is continuously active, setting the stage for upcoming missions like Europa Clipperton used to map, sample, and understand the energy flows that might sustain life. In the quiet of your own space, let the thought of this hidden, dynamic ocean unfold, as though you are floating above it, watching its silent movements, knowing that each chemical signature is a message from a world both alien and intimately connected to the possibilities of life beyond Earth. Chapter 4: Jupiter's Gravity in Europa's Hidden Heat. Europa's hidden ocean does not exist in isolation. It is powered by forces far beyond its icy surface. The relentless pull of Jupiter's gravity stretches and flexes the small moon in a cosmic rhythm, generating heat through a process scientists call tidal heating. Unlike Earth, where internal radioactive decay warms the planet, Europa's warmth comes from external stress, the constant squeezing and releasing as it orbits the gas giant. Imagine holding a stress ball in your hand, squeezing it over and over, feeling it grow warmer in your grasp. Now imagine that on a planetary scale, every orbit producing just enough energy to keep water liquid beneath miles of ice. This tidal heating is uneven, concentrated in regions like Terra Reio, where Webb observed the freshest chemical signals. The chaos terrains we see on the surface are not accidents. They are the direct result of this gravitational ballet. Ice cracks, shifts, melts slightly, and ray freezes, creating the perfect conduits for ocean chemistry to reach the surface. Webb's data shows us the fingerprints of this process: salts, carbon compounds, and hydrogen peroxide accumulating in precise, unexpected patterns, betraying a system that is dynamic, energized, and persistent. The ocean beneath is insulated yet restless, fed by a combination of tidal energy and chemical gradients that resemble the conditions around hydrothermal vents on Earth. Picture the rocky seafloor beneath Europa's ocean, pushed and pulled by tidal forces, creating hotspots where chemical reactions thrive, releasing nutrients and minerals into the water. On Earth, such vents are hotspots for life, harboring microbes that exist without sunlight, powered only by chemistry. Europa's ocean, though dark and alien, appears capable of sustaining similar processes. The significance is profound. This is a world where energy flows constantly from below, where the ice above is thin and fractured enough to allow chemical exchange, and where the ocean's contents are slowly being delivered to the surface. For you, the listener, it means that Europa is not a static, frozen sphere. It is a living laboratory operating quietly for billions of years, powered by the gravitational forces of a giant planet, whispering its secrets to a telescope millions of miles away. Every crack, every chemical signature, is a line in a story that humanity is only beginning to read, a story of energy, motion, and the tantalizing possibility of life beyond Earth. Chapter 5, The Strange Chemistry of Terra Raio. Terra Raio is not just another region on Europa. It is the epicenter of chemical mysteries that James Webb has unveiled for the first time. From orbit, the area looks like a frozen jigsaw puzzle with ice blocks shattered, tilted, and rotated in patterns that defy ordinary physics. Webb's infrared data revealed an array of chemicals clustered precisely in these chaotic regions. Chemicals that should have been obliterated instantly by the harsh radiation from Jupiter. Sodium chloride, a simple salt we use in kitchens on Earth, was concentrated in patches atop the fractured ice, and atop it, carbon dioxide glistened in Webb's infrared imaging. These chemical deposits are not random, they are fresh, geologically recent, and directly linked to what is happening beneath the surface. It's as if the ocean below is exhaling, sending pulses of material upward through fractures in the ice, leaving behind a chemical signature visible across millions of miles. Hydrogen peroxide was also detected, forming unusually in equatorial regions where it was expected to be scarce. On Earth, such oxidants are vital for life, acting as chemical energy sources for organisms. On Europa, they accumulate in direct association with carbon and salt, forming natural pockets of energy that could, in theory, sustain microbial life. Webb's findings suggest that the chaos terrain is not merely a geological curiosity, it is a chemical interface, a living laboratory where oceanic material meets the frozen surface and reactions occur in a system that is active, dynamic, and ongoing. The patterns of these chemicals tell a story that is both thrilling and unnerving. Europa is not inert. It is alive in a chemical sense, continuously exchanging material between its hidden ocean and the surface ice. For the listener, this is more than a distant astronomical fact. It is an invitation to imagine a world where life might exist without sunlight, where energy is provided by chemistry and heat, and where the frozen surface is merely a thin veil over an ocean brimming with potential. As we explore Terra Raio in the coming chapters, consider each chemical signature as a language, a story billions of years in the making is, and a whisper that tells us this moon is far more extraordinary than we ever imagined. Chapter 6. Carbon and Life's Building Blocks. One of the most astonishing discoveries Webb made at Terra Raio was the presence of carbon compounds rising from the ocean below. Carbon is fundamental to life on Earth. It forms the backbone of every molecule in every cell. The detection of carbon dioxide frozen into Europa's ice is not proof of life, but it is the closest we have ever come to confirming that the ingredients for life are present in this distant ocean. Webb's instruments were able to measure not only the presence of carbon, but also the ratios of carbon isotopes, comparing carbon-12 with carbon-13. The ratios suggest that this carbon did not arrive randomly via comets or meteors. It did not form from radiation acting on existing compounds on the surface. Instead, it came from the interior of the moon, most likely dissolved in the ocean below and transported upward through cracks in the ice. Imagine a sealed jar with mud at the bottom and water above, slowly releasing gases that travel upward, dissolving in water, and then freezing at the top. This is what Europa is doing on a planetary scale. Every carbon molecule detected by Webb is a trace of a chemical pathway that has been running uninterrupted for millions of years. Combined with the salts and oxidants also detected, this forms a complete chemical environment capable of supporting life as we understand it. The energy from tidal heating, the presence of salts, the distribution of oxidants, and now carbon, all converge to suggest that Europa's ocean is a viable habitat, For the audience, it is difficult not to feel a thrill, imagining a world beneath miles of ice where chemistry mirrors the early conditions on Earth that eventually gave rise to life. The implications are profound. If Europa's ocean can maintain these chemical processes, it may represent a second experiment of life in our solar system. The presence of carbon, so freshly deposited, is a whisper from the ocean, hinting at biological or pre-biological chemistry, a tantalizing secret that humanity is only beginning to read. Webb's data transforms our understanding of what makes a moon habitable, revealing that beneath the frozen surface lies a dynamic, chemically active world that may hold answers to some of the oldest questions we can ask. How does life begin? Is it rare, or is it an inevitable outcome of chemistry and energy? Europa now invites us to listen carefully, to follow the clues, and to imagine a life-rich ocean hidden just out of reach, beneath an icy lid 500 million miles away. Chapter 7. Hydrogen peroxide and chemical energy. Among the unexpected discoveries Webb made at Terra was the high concentration of hydrogen peroxide in regions near the equator, where scientists had predicted it would be minimal. On Earth, hydrogen peroxide is a reactive chemical that can store and release energy, providing a critical source of fuel for life's processes. On Europa, this compound forms when radiation from Jupiter's intense magnetic field interacts with the water ice on the surface, breaking molecules apart and recombining them into oxygen. What makes the discovery so remarkable is the location. Hydrogen peroxide is accumulating precisely in the same chaos regions where carbon dioxide and sodium chloride are being deposited. This alignment suggests a natural system of chemical energy generation and transport, where oxidants from the surface could potentially make their way into the ocean below through cracks and porous ice layers. In other words, Europa is producing its own energy currency, and it is doing so in a coordinated, repeatable fashion that has been ongoing for millions of years. Imagine standing above Terra, the equatorial sun casting long shadows across jagged ice, while chemical reactions unseen by the naked eye pulse with life-sustaining potential miles below. This is more than an isolated reaction. It is part of a dynamic chemical ecosystem that bridges the frozen crust and the hidden ocean, creating conditions that pressure on Earth support microbial life. Webb's data reveals not just the presence of these compounds, but the patterns and concentrations, showing us the precise locations where the moon's chemistry is most active. For the listener, this is a chance to envision a world where energy and matter circulate naturally, where chemical gradients act as highways connecting the surface and the ocean, and where life, or something remarkably life, could exist without ever seeing the light of a sun. The equatorial concentration of hydrogen peroxide is a subtle hint that Europa's internal and external forces, tidal heating, ocean currents, and radiation, combine to sustain chemical processes that could, in theory, power ecosystems, much like the hydrothermal vent communities on Earth. As you follow this story, let the interplay of these forces sink in. Europa is alive chemically, constantly exchanging materials, building gradients, and preparing environments that are as astonishing as they are alien. Chapter 8. Ice shell dynamics and surface. Refreshing. The ice covering Europa is not a static, frozen shell. Webb's observations, combined with data from Juno's microwave radiometer, reveal a complex, fractured layer that is constantly being renewed. Crystalline ice appears alongside amorphous ice in the same regions, a combination that should be impossible under the relentless radiation of Jupiter. Crystalline ice requires warmth or some process to organize its molecules, while amorphous ice forms when water freezes too quickly or is disrupted by radiation. Their coexistence indicates that Europa's surface is being replenished continuously, either by heat from below, by ocean water seeping upward, or by a combination of both. This dynamic layer means that chemical signatures from the ocean can reach the surface relatively intact, giving Webb a rare glimpse of material that is only thousands to hundreds of thousands of years old, a geological heartbeat compared to the moon's 4.5 billion year history. Each crack, fracture, and porous pocket acts as a conduit for salts, carbon, and oxidants, allowing these materials to accumulate and interact in ways that create a mosaic of chemical activity visible from space. For the listener, imagine walking across an icy landscape where the ground beneath your feet is not uniform, but a sponge-like network of fractures and voids, constantly shifting, absorbing energy from tidal forces, and letting ocean chemistry seep through. This ice shell is Europa's interface, its protective barrier and its translator, delivering whispers from the deep ocean to the sensors of a telescope millions of miles away. Webb's detection of fresh chemical deposits is only possible because the ice is young, active, and porous, meaning Europa's hidden ocean is not sealed off, but in constant conversation with the surface. The processes that maintain this cycle, tidal heating, oceanic convection, radiation chemistry, create an environment where life, if it exists, could access energy and nutrients without ever breaching the icy lid. For you, the listener, the ice is more than a barrier. It is a living system, a bridge that makes Europa legible, revealing the hidden movements and interactions that sustain a dynamic, habitable environment miles below the surface. Chapter 9. The importance of double ridges. Europa's surface is etched with countless lines, long parallel features called double ridges that stretch for hundreds of miles across the icy landscape. These ridges are not random, they are structural signatures of the forces shaping the moon's crust. Each ridge consists of two elevated walls with a valley in between, often consistent in width and height, resembling train tracks frozen in ice. Scientists believe these formations may result from shallow water pockets within the ice shell freezing and expanding, or from fractures that allow ocean water to rise and refreeze along fault lines. Webb's infrared observations cannot resolve individual ridges in detail, but the chemical signatures associated with chaos regions suggest that double ridges may also serve as conduits for the movement of salts, carbon, and oxidants from the hidden ocean to the surface. These ridges are more than geological curiosities. They are potential windows into the moon's interior, marking areas where ocean material has likely influenced the crust recently. For the listener, picture standing at the edge of a ridge, the frozen walls rising on either side, the valley beneath filled with ice that has been shaped by a combination of ocean pressure, tidal flexing, and chemical interactions. The patterns of these ridges, repeated across the equatorial regions, suggest a rhythm to Europa's geological processes, a pulse of energy moving from the ocean below through the ice above. Webb's chemical maps indicate that regions with the freshest deposits of salts and carbon often align with these ridges, hinting that the processes forming them are directly connected to the dynamic activity beneath the surface. In essence, double ridges are markers of activity, guiding scientists toward the most chemically interesting areas for future exploration. As you visualize this, imagine the possibility that landing a probe here could allow us to sample ocean material indirectly, scooping up ice that carries chemical traces from miles below. Europa's ridges, therefore, are not only a testament to the moon's geophysical history, but also a roadmap for discovering the secrets of its hidden ocean. Chapter 10. Lenticulae. Signs of convection scattered across Europa's icy surface are small, oval features known as lenticulae, ranging from a few miles to a few dozen miles in diameter. Some are domed, others sunken, and a few appear flat, yet all share a common origin. They are thought to result from warmer, softer ice rising slowly through the colder upper shell. This process, called convection, may act like a planetary scale pot of porridge, where blobs of heated ice rise and disrupt the crust above. Webb's chemical data, combined with previous studies, suggests that these rising blobs are transporting salts, carbon, and oxidants from the ocean beneath toward the surface. Lenticulae, therefore, are not mere surface features. They are evidence of Europa's internal dynamics and a mechanism for material exchange between ocean and crust. For the listener, envision these lenticulae as bubbles in a frozen sea, slowly swelling and then solidifying, carrying chemical clues that tell a story of movement, energy, and potential habitability. Unlike plumes or dramatic eruptions, this process is subtle and persistent, operating over thousands or millions of years, but its impact is profound. It keeps the surface chemistry fresh, provides a pathway for energy transfer, and allows oceanic signatures to remain detectable by instruments like Webb. The combination of chaos terrains, double ridges, and mesmerizing forms a coherent picture. Europa's surface is alive in a geological sense, constantly reshaped by internal forces, while also serving as a window into the ocean below. As you imagine walking across this frozen world, each bubble, each ridge, each fracture is a page in a history of activity, chemistry, and hidden energy, telling a story that humans are only beginning to read and interpret. The mesmerizing mark the subtle, persistent heartbeat of Europa, revealing that beneath the seemingly static ice lies a world in motion, alive with potential chemical energy, and perhaps the conditions necessary for life. Chapter 11. Hydrothermal vents and possible life beneath Europa's icy ocean lies a rocky seafloor shaped and heated by the same tidal forces that flex the moon's crust. Scientists suspect that hydrothermal vents, similar to those found on Earth, may exist here, creating localized hotspots where water interacts with rock, dissolving minerals and releasing chemical energy. On Earth, these vents are oases for life, supporting dense ecosystems of microbes to worms and other extremophores that thrive without sunlight. Webb cannot see the seafloor directly, but the chemical signatures on the surface, fresh sodium chloride, carbon compounds, and hydrogen peroxide concentrated in chaos regions, strongly suggest that active hydrothermal processes are influencing the ocean above. Picture the seafloor 60 miles beneath the ice, total darkness, crushing pressure, and swirling mineral-rich water erupting from chimneys, carrying energy and nutrients into the surrounding cold ocean. Each chemical signal Webb detects at the surface is a hint of these hidden processes, like faint footprints left in the sand by creatures we cannot see. For the listener, this is an invitation to imagine a parallel to early Earth, where life first emerged around hydrothermal vents. The combination of liquid water, heat, chemical gradients, and energy sources creates a setting remarkably similar to the conditions that may have sparked life on our planet. If Europa has life, it is likely microbial, slow-growing, then chemically efficient, forming colonies near these vents where the chemistry is richest. Even if life does not exist, the presence of active hydrothermal systems means the ocean is a dynamic, habitable environment, constantly recycling nutrients and energy and sending signals upward through fractures in the ice. The thought that a moon orbiting 500 million miles away may host such complex chemistry, and possibly life, is both exhilarating and humbling, reminding us how much of the universe remains unseen and how closely chemistry and habitability are intertwined. Chapter 12. The hidden ocean is a living system. Europa's ocean is more than just a body of water. It is a chemically dynamic system interacting with the icy shell above and the rocky mantle below. The salts, carbon compounds, and hydrogen peroxide Webb detected form gradients and pockets of chemical energy that flow through fractures and porous ice, suggesting a constantly circulating environment. Tidal heating drives convection in the ocean, creating currents that move warm water and dissolved minerals around, distributing energy throughout the system. This circulation is crucial. It ensures that oxidants from the surface and reduct and tests from hydrothermal activity below can meet it, creating chemical disequilibrium that life on Earth exploits for energy. For the listener, imagine the ocean as a vast, hidden bloodstream, pumping chemical energy and nutrients, connecting the seafloor and the fractured ice above. This dynamic system means that Europa is not a static, dead world. It is a living chemical engine, slowly but steadily exchanging matter and energy. The freshest deposits on the surface are a direct reflection of this activity, giving Webb a rare window into the ongoing processes in the ocean below. The combination of surface chemistry, ice dynamics, and internal heating forms an interconnected network, sustaining a habitable environment across spatial scales from kilometers of ice to tens of miles of ocean depth. Each chemical fingerprint, is a signal from a system that has been operating undisturbed for billions of years, quietly maintaining conditions that, on Earth, would support life. As you imagine drifting over Europa, looking down on a frozen, fractured surface, know that beneath lies a vast, hidden ocean alive with chemistry, energy, and possibility, a world whose secrets are only now beginning to reach our instruments, and perhaps our imagination. Chapter 13, Europa's Ice Shell, a porous gateway. The ice covering Europa is not a simple, solid lid sealing the ocean beneath. Webb's observations, combined with data from Juno's microwave radiometer, reveal a complex, porous, fractured structure. This shell is riddled with tiny cracks, voids, and irregularities that, while too small for large organisms to traverse, allow gases and dissolved chemicals to migrate from the ocean below to the surface. These micropathways are critical for understanding how salts, carbon, and oxidants reach the icy crust, providing fresh material for Webb to detect. Imagine the ice as a slowly breathing sponge, absorbing energy from tidal flexing, allowing chemical material to percolate upward over thousands of years. Each pore and crack serves as a channel for chemical conversation between the ocean and surface, keeping the surface chemistry young, active, and observable. Crystalline ice and amorphous ice coexist within these layers, a sign that the surface is continuously refreshed. Crystalline ice forms under warmth as slow reorganization, while amorphous ice results from rapid freezing or radiation disruption. Their juxtaposition indicates ongoing processes, whether from ocean material seeping upward or localized heating that allows molecules to realign. For the listener, visualize walking on fractured ice that feels solid yet subtly shifting underneath, each footstep touching a surface that is part of a dynamic system constantly renewed from below. This porous ice shell transforms our understanding of habitability. It not only protects the ocean but also mediates the transport of energy and chemicals, providing pathways that could support life indirectly. Europa is no longer an inaccessible frozen moon. Its ice is a living interface, actively exchanging material with the hidden ocean beneath, making it possible for telescopes and future spacecraft like Europa Clipper to read the chemical story of the ocean without penetrating miles of ice. Chapter 14, The Mystery of Plumes. For years, scientists hoped that Europa might be venting water from its hidden ocean in dramatic plumes, similar to those seen on Saturn's moon Enceladus. Such plumes would provide direct access to ocean material, allowing spacecraft to sample its contents without landing. Hubble detected possible plume activity near the South Pole in 2013, with tentative observations in 2016 and 2017. However, Webb's first high-sensitivity infrared scans found no evidence of active plumes during its observations. This absence is significant. It indicates that if plumes exist, they are weaker, sporadic, or occur only at specific points in Europa's orbit when tidal stress is maximal. While disappointing for those hoping for an easy sampling route, it reveals something deeper about the ocean's surface interaction. Europa may rely more on subtle chemical leakage through chaos regions, fractures, and porous ice than on violent eruptions. The chemical fingerprints Webb detected, salts, carbon, and hydrogen peroxide, support this idea, showing that the ocean communicates with the surface continuously but gently. For the listener, imagine standing on a frozen plain, expecting a dramatic geyser to erupt, only to see a silent, fractured surface that nevertheless hums with chemical activity from beneath. This quiet leakage is enough to refresh the surface and provide pathways for chemical energy, maintaining the dynamic environment that could support life. Future missions like Europa Clipper will target these chaos regions and cracks, using ice-penetrating radar, mass spectrometry, and remote sensing to read the signals that Webb first detected. The absence of plumes does not diminish the ocean's vitality, it highlights Europa's subtle complexity, where chemical exchange occurs over millennia through fractures and pora, ice rather than dramatic eruptions, revealing a moon alive in ways both quiet and extraordinary. Chapter 15, Tidal Flexing, the heartbeat of Europa. Europa's ocean and ice shell are alive not just because of chemistry, but because of the relentless, invisible force of Jupiter's gravity. The moon's slightly elliptical orbit means that it is alternately pulled and released with every revolution, causing its interior to flex and stretch. This tidal flexing generates heat deep within the ice and the rocky mantle, a process known as tidal heating, which is the engine keeping the subsurface ocean liquid. Imagine holding a stress ball, squeezing it rhythmically, feeling it warm as you apply pressure and relax it repeatedly. Now scale that action up to an entire moon, with the force of Jupiter constantly kneading its interior. This energy is unevenly distributed, concentrating in regions like Terra Raya, where Webb detected the freshest chemical signals on the surface. The flexing causes the ice to fracture, melt slightly, and refreeze, creating the chaos terrains and double ridges that act as conduits for material to rise from the ocean below. This tidal heartbeat doesn't just move ice, it drives convection in the ocean, redistributing salts, carbon, and oxidants, creating a chemically dynamic environment over hundreds of miles. For the listener, imagine that each orbit Europa completes, miles beneath the ice, currents shift, energy flows, and chemical gradients fall, producing pockets that could, in theory, sustain microbial life. Even without direct evidence of organisms, the combination of heat, liquid water, and chemical flux creates conditions remarkably similar to the early Earth, where life first emerged around hydrothermal vents. Webb's detection of chemical patterns at the surface, aligned with known regions of maximum tidal stress, provides indirect but compelling evidence that Europa's ocean is active, energized, and interacting continuously with the overlying ice. Every fracture ridge and lentice CU law is not only a geological feature but a marker of this energy flow, a window into the moon's interior dynamics. The tidal forces that flex Europa are constant, predictable, and persistent over billions of years, ensuring that the subsurface environment remains chemically rich and physically dynamic. For the listener lying back, eyes closed, it is a comforting yet inspiring thought, a hidden ocean, constantly in motion, alive with chemistry, beneath an icy shell that breathes in rhythm with Jupiter, shaping the world as alien as it is fascinating. Understanding this heartbeat is essential for future exploration, guiding spacecraft to regions where the most recent and chemically rich material is likely to surface, maximizing our chances of observing and perhaps even sampling the ocean indirectly. Europa's heartbeat is slow by human standards, but over millennia, it shapes the moon, sustains its chemistry, and keeps alive the possibility of hidden life in one of the solar system's most extreme environments. Chapter 16. The Dynamic Interface. Ocean meets ice. The true wonder of Europa lies not only in its hidden ocean or fractured ice, but in the dynamic interface where the two meet. Webb's infrared observations revealed that this interface is chemically active with salts, carbon, and hydrogen peroxide concentrated in regions of recently disturbed ice. This suggests a continuous exchange between the ocean below and the icy crust above, where material from the depths is delivered to the surface, refreshed, and exposed to radiation. Think of it as a planetary scale laboratory where chemical reactions unfold over thousands of years, quietly reshaping the surface and maintaining energy gradients necessary for habitability. The ice shell acts as both shield and mediator. It protects the ocean from the harsh radiation of space while simultaneously allowing materials to migrate upward, creating pockets of chemical energy. Crystalline ice and amorphous ice coexist in these regions, indicating active resurfacing processes. Crystalline ice forms when water molecules have the chance to organize, while amorphous ice results from rapid freezing or radiation disruption. The juxtaposition shows that Europa's surface is young, active, and chemically connected to the ocean below. Webb's detection of fresh deposits, combined with Juno's microwave data showing a porous, fractured shell, reinforces the picture of a dynamic interface that is constantly renewed. For the listener, imagine walking across a frozen plain where the ground beneath is not uniform, but a sponge-like network, subtly shifting, absorbing energy, and allowing chemical material to percolate upward. Each fracture and void acts as a chemical conduit, creating a system where oxidants from the surface and reductant tests from hydrothermal activity below can mix, generating chemical disequilibrium that life on Earth exploits for energy. Even if Europa's ocean is hidden beneath miles of ice, the interface ensures that material flows, energy circulates, and the surface remains chemically readable. This dynamic boundary is critical for future missions like Europa Clipper, which will fly through these regions, sampling the thin atmosphere and mapping the surface chemistry to understand the interactions between ice and ocean. The interface is subtle, persistent, and remarkably efficient. It maintains Europa as a chemically active, habitable world, continuously feeding its own frozen surface with evidence of life-sustaining processes occurring far below, out of sight, yet intimately connected to every fractured chemical fingerprint Webb has detected. Chapter 17. The Hidden Energy of Oxidants. One of the most remarkable revelations from Webb's observations is the distribution of oxidants across Europa's surface, particularly hydrogen peroxide. These compounds are more than chemical curiosities. They are carriers of energy that could, in theory, sustain life beneath the ice. Radiation from Jupiter splits water molecules on the surface, creating reactive oxidants that slowly migrate downward through fractures in porous ice. The result is a continuous transfer of potential chemical energy from the irradiated surface to the ocean below, where it can meet reductant tests coming from hydrothermal vents. Picture Europa as a giant battery, with oxidants on top and reductant tests below, creating natural chemical currents capable of powering biological processes. The concentration of hydrogen peroxide in equatorial chaos regions, rather than at the poles as previously expected, demonstrates how the chemistry of the surface is closely linked to the subsurface ocean. This spatial arrangement, coupled with the presence of salts and carbon compounds, suggests that Europa's chemical environment is highly organized, a subtle choreography maintained over millions of years. For the listener, imagine the ice as a living membrane, constantly receiving energy from above while distributing it below, sustaining chemical disequilibrium that on Earth would fuel microbial ecosystems. Webb's data reveals that these oxidants are freshly deposited, indicating active transport from the surface to the ocean in geological yesterday to mescal. This dynamic energy flow is critical to Europa's habitability, creating pockets where chemical reactions can occur continuously, maintaining a balance of materials and energy in a system that has been operating quietly for billions of years. It is as if the moon is alive chemically, breathing energy into its hidden ocean, sustaining a cycle that mimics the processes that made early Earth habitable. Understanding this distribution and flow of oxidants is essential for future exploration, guiding spacecraft to the regions most likely to reveal the interaction between surface chemistry and oceanic activity, and ultimately, to hint at whether life could exist in these alien seas. Chapter 18. Salts. The fingerprint of the ocean. Sodium chloride, a simple compound familiar on Earth, is one of the most telling signs of Europa's dynamic ocean. Webb detected concentrated patches of salt precisely in chaos regions like Terra, indicating that the ocean below is actively supplying material to the surface. Unlike other salts expected to dominate the ocean, magnesium-rich compounds are surprisingly weak, suggesting that Europa's ocean chemistry is influenced by localized hydrothermal activity or specific rock types on the seafloor. For the listener, imagine standing on fractured ice with bright, crystalline salt deposits scattered across the surface, each crystal a fingerprint of the ocean below, telling the story of chemical processes occurring miles beneath. These salts are freshly exposed, meaning they have been transported from the ocean to the surface in recent geological time, preserved long enough for Webb to detect. They are not the result of random impacts or surface radiation. Their concentrated distribution aligns with chaotic, disrupted terrains, confirming that the ocean communicates with the ice in a controlled, continuous manner. This chemical fingerprint does more than reveal ocean surface interaction. It provides insight into the energy and nutrient distribution within Europa's hidden ocean, the pathways for potential life, and the processes that refresh the surface and maintain habitability. Salts combined with carbon compounds and oxidants create a complex chemical landscape that mirrors early Earth conditions, where similar interactions around hydrothermal vents likely gave rise to life. For the listener, this is a chance to visualize Europa not as a dead, frozen moon but as a living laboratory, where every salt crystal, every chemical gradient, and every fractured ice patch is a signal from a dynamic, habitable ocean beneath. Webb's detection of these salts gives humanity its first tangible evidence of the ocean's compositions, opening the door for future missions to explore these regions, map the chemical pathways, and perhaps sample materials that could reveal whether life exists in this alien yet familiar world. Chapter 19: Carbon Isotopes. Clues from below. Among the most compelling pieces of evidence Webb provided is the measurement of carbon isotopes in Europa's surface deposits. Carbon exists primarily as carbon-12, but a small fraction is carbon-13, and the ratio between these isotopes can reveal the origin of the material. On Earth, biological processes preferentially use carbon-12, leaving a distinct signature, while geological processes create a different balance. Webb measured the ratio of carbon-12 to carbon-13 in the carbon dioxide trapped in Europa's ice and found that it closely matches the expected signature of material sourced from within the moon itself, rather than delivered randomly by comets or meteors. This strongly supports the conclusion that the carbon is rising from the hidden ocean below, carried upward through fractures and chaotic terrain, rather than being a surface product of radiation chemistry. For the listener, imagine racing a subtle chemical fingerprint across miles of fractured ice, each molecule of carbon telling a story of processes occurring deep beneath the frozen surface. The isotopic data suggests that Europa's ocean is chemically active, circulating materials from the seafloor to the ice shell in a continuous cycle. This provides a rare glimpse into processes happening in a place humans have never visited and may never see directly. The freshly deposited carbon, combined with salts and oxidants, forms a chemically rich environment that mirrors the ingredients necessary for life. Even without confirming the presence of organisms, these signatures indicate that the building blocks for life are present and dynamically replenished. Webb's measurements offer the first quantitative link between Europa's ocean and its surface chemistry, revealing an interconnected system where chemical energy, carbon, and nutrients are actively cycled. For you, the listener, this is an opportunity to imagine a world where molecules carry messages across miles of ice, a silent network of chemical pathways connecting the ocean surface, whispering hints of habitability in a language of isotopes, salts, and reactive compounds. Chapter 20: Chemical Disequilibrium, a window into habitability. The combination of salts, carbon, and hydrogen peroxide on Europa's surface reveals a system far from chemical equilibrium. In planetary science, chemical disequilibrium is a critical marker for potential habitability because it indicates energy gradients that life can exploit. Webb's data shows that oxidants produced by radiation at the surface coexist with reductant tests supplied by hydrothermal activity from the seafloor, creating pockets where reactions could release energy continuously. Think of these zones as invisible engines, sustaining a dynamic environment over thousands or millions of years. For the listener, imagine a frozen landscape where energy flows silently beneath your feet, chemical reactions ongoing even as the surface appears still. The spatial alignment of fresh salts, carbon compounds, and oxidants in chaos terrains and near-lent ICULAE demonstrates that Europa's ocean is not sealed off. It communicates chemically with the ice above. These gradients are analogous to conditions near hydrothermal vents on Earth, where microbial life thrives without sunlight, powered only by chemistry. The presence of such a system on Europa suggests that, if life exists, it could exploit these energy flows to survive, maintaining a habitable niche in a completely alien environment. Webb's observations provide the first comprehensive view of this chemical disequilibrium on a planetary scale, showing that Europa's hidden ocean and surface are coupled in a way that supports continuous chemical cycling. This coupling maintains a young, reactive surface that allows scientists to infer the ocean's composition, energy sources, and potential habitability without drilling miles through ice. For the listener lying back, absorbing the story, it is astonishing to realize that a moon 500 million miles away operates a subtle, persistent, and life-sustaining chemical engine beneath a frozen crust, quietly maintaining conditions that might be ideal for life, and providing a natural laboratory for the first detailed study of an alien ocean world. Chapter 21. Europa's Ice Shell. Structure and function. Europa's ice shell is far from a simple, static barrier separating the hidden ocean from the vacuum of space. Recent data from Webb, combined with Juno's microwave radiometer, reveals a complex structure characterized by fractures, voids, and porous regions that allow chemical material to migrate from the ocean below to the surface. This shell is composed of both crystalline and amorphous ice, coexisting in ways that reveal continuous resurfacing processes. Crystalline ice forms when water molecules have time to organize into ordered patterns, while amorphous ice results from rapid freezing or disruption by radiation. The juxtaposition of these ice types indicates that the surface is young and dynamic, constantly refreshed by processes originating from the ocean or localized heating within the ice shell. For the listener, imagine standing on a frozen landscape that feels solid but subtly shifts beneath your feet, as chemical material and energy percolate upward from below. Each crack and pore in the ice acts as a conduit, transporting salts, carbon, and oxidants from the ocean into newly formed surface layers, creating a mosaic of chemical activity detectable by Webb's instruments. This dynamic ice layer is essential for maintaining Europa's habitability, serving as both a protective barrier and a chemical interface. While the ice shields the ocean from Jupiter's intense radiation, it simultaneously allows the surface to receive material from below, maintaining energy gradients necessary for potential life. The combination of tidal heating, ocean currents, and surface radiation creates a chemically and physically active interface, where energy flows continuously, and the surface chemistry remains young, observable, and dynamic. Webb's detection of fresh chemical deposits provides the first direct evidence of these processes, showing that Europa is not a frozen, inert moon but a world in constant chemical motion. Understanding the structure and function of the ice shell is critical for future exploration, guiding missions like Europa Clipper to the most chemically active regions and informing landing strategies to maximize the opportunity to study oceanic material indirectly. The ice is a living system in itself, slowly renewing and reshaping the surface while preserving clues about the hidden ocean, creating a layered, interactive environment where chemistry, energy, and geology converge to maintain conditions suitable for life. Every fracture, every pore, and every newly formed crystalline patch is a window into processes occurring miles below, providing scientists with a rare glimpse into a planetary ocean that has been evolving for billions of years and offering the listener a way to visualize Europa as a chemically alive, dynamic world waiting to reveal its secrets. Chapter 22. The significance of surface chemistry. The surface chemistry of Europa, revealed by Webb's infrared observations, provides a window into the hidden ocean's composition and activity. Sodium chloride, carbon dioxide, and hydrogen peroxide are concentrated in chaos-terranes and lenticula, suggesting that the moon's ocean is actively communicating with the ice above. These chemical signatures are fresh, geologically recent, and unlikely to survive long under Jupiter's intense radiation, indicating a continuous process of replenishment from below. For the listener, picture a frozen landscape scattered with crystalline salt deposits and ice blocks fractured and jumbled like pieces of a broken puzzle. Each chemical concentration is a direct signal from the ocean below, a trace of processes occurring miles beneath the surface that humans can now read from millions of miles away. The presence of these compounds is not random. Sodium chloride indicates a salty ocean, carbon compounds reveal the basic building blocks for life, and hydrogen peroxide represents stored chemical energy. Together, they form a network of chemical interactions that mirrors the conditions near Earth's hydrothermal vents, where life thrives without sunlight. Webb's data shows that the interface between ocean and ice is not static. It is a dynamic system where chemical gradients allow oxidants from the surface to meet reductant tests from below, creating disequilibria that could power life. This understanding transforms Europa from a distant, frozen moon into a world of potential habitability, a system where energy and nutrients are actively cycled, and the surface serves as a readable interface for scientists. Future missions, including Europa Clipper, will rely on these chemical signals to identify the most active regions for study, using ice-penetrating radar and mass spectrometry to infer oceanic conditions without drilling through miles of ice. For the listener, this is an opportunity to imagine Europa as a living laboratory, where every chemical deposit is a clue, every fracture a pathway, and every measurement a story from a world that has been quietly active for billions of years. Understanding surface chemistry is the key to interpreting the moon's hidden ocean and assessing its potential to host life, making it one of the most exciting discoveries in planetary science and a gateway for future exploration. Chapter 23, Terra. The hotspot of activity. Terra is the most chemically active and visually striking region on Europa. A chaotic expanse of fractured ice blocks, tilted slabs, and broken terrain that reveals the moon's hidden processes. Webb's infrared imaging shows concentrated deposits of sodium chloride, carbon dioxide, and hydrogen peroxide within this area, marking it as a hotspot where the ocean below is communicating most directly with the surface. For the listener, imagine standing on a frozen plain where every fractured slab of ice is a frozen fingerprint, a direct signal of material that has risen from the ocean miles below. The presence of fresh salts indicates active ocean upwelling, while carbon compounds suggest the transport of life's fundamental building blocks to the surface. Hydrogen peroxide, concentrated in equatorial regions like Terra, provides chemical energy that could power microbial life if it exists. The combination of these compounds, aligned precisely with chaotic terrain, shows a coordinated chemical system rather than random deposition. Unlike plumes, which appear sporadic and sometimes absent, the chemical activity at Terra occurs continuously over geological temescals, ensuring that surface deposits remain fresh enough to be detectable. For the listener lying back and imagining this scene, Terra becomes more than a map location. It is a living laboratory where chemistry, energy, and geological activity intersect in a moon-sized ecosystem that has been operating silently for billions of years. Webb's observations allow scientists to infer ocean currents, heat flow, and chemical gradients from these surface patterns, providing an indirect but precise method to study Europa's habitability. Each crack, each chaotic block, and each concentrated chemical deposit is evidence that the moon's interior and surface are intimately connected, forming a system where energy and matter flow constantly, refreshing the surface and maintaining a dynamic environment. Understanding Terra is critical for targeting future exploration, guiding spacecraft to the regions most likely to reveal active chemistry, and possibly the ingredients for life. For the listener, Terra is a reminder that even on a distant, icy moon, processes akin to early Earth may be unfolding, a chemical and geological story billions of years in the making. Chapter 24, The Silent Ocean. Miles of hidden water beneath Europa's ice shell lies an ocean that dwarfs all of Earth's combined seas, averaging roughly 60 miles deep and stretching across the entire moon. This ocean is a vast, hidden reservoir of water, energy, and chemical potential, constantly interacting with the ice above and the rocky mantle below it. Webb's observations indicate that this ocean is not stagnant. Chemical signatures on the surface suggest that salts, carbon compounds, and oxidants are transported upward, hinting at dynamic currents and convection within the water below. For the listener, imagine diving into complete darkness where pressure is crushing. Temperatures swing between near freezing and several hundred degrees near hydrothermal vents, and chemical energy flows silently through a liquid expanse far larger than any ocean on Earth. Tidal heating generated by Jupiter's gravity warms the ocean unevenly, creating hotspots that doctor movement, mix chemicals, and refresh the ice above. This constant motion ensures that surface deposits remain young, chemically rich, and detectable by Webb. The distribution of salts and carbon indicates that hydrothermal activity at the seafloor may be producing mineral-rich plumes. contributing nutrients and energy to the ocean currents, while hydrogen peroxide from the surface provides a continual supply of oxidants. This creates a self-sustaining system, where the exchange between ocean and ice maintains chemical disequilibrium that could power life in a manner similar to Earth's deep-sea vents. For the listener, the silent ocean beneath Europa is a world unto itself, teeming with unseen chemical activity and energy. A hidden laboratory operating over billions of years, quietly shaping a habitable environment under a frozen crust. Webb's infrared data, coupled with the understanding of ice shell dynamics and tidal heating, paints a picture of Europa as a living system, where water, energy, and chemistry combine in a delicate balance that has persisted for geological eons, offering the tantalizing possibility that this ocean may host life, or at the very least, the conditions for it. Chapter 25. The role of tidal heating in ocean dynamics. Europa's hidden ocean owes its existence, not to internal radioactive decay, as on Earth, but to the relentless pull of Jupiter's gravity. The Moon's slightly elliptical orbit causes it to flex and stretch with every revolution, generating heat through a process known as tidal heating. This energy warms the subsurface ocean and parts of the ice shell, creating convection currents that circulate salts, carbon compounds, and oxidants throughout the water. For the listener, imagine squeezing a stress ball repeatedly, feeling it grow warmer with each breath. Now scale the concept to a planetary scale, with the gravitational force of Jupiter kneading Europa's interior continuously for billions of years. The heat is unevenly distributed, concentrating in regions like Terra Rio and other chaotic terrains, where Webb detected the freshest chemical signals on the surface. These areas serve as conduits for ocean material to reach the ice, creating the chemical fingerprints that Webb measured: concentrated sodium chloride, carbon dioxide, and hydrogen peroxide. Tidal heating also drives ocean currents, mixing material from the seafloor with water nearer the ice shell, sustaining a chemically dynamic environment that mirrors the conditions found around Earth's hydrothermal vents. Even without confirming the presence of life, this energy flow creates a habitable environment, supplying both energy and nutrients to potential microbial ecosystems. Webb's observations provide indirect evidence of this activity. The alignment of chemical deposits with predicted regions of maximum tidal stress suggests that Europa's ocean is actively interacting with the ice above. For the listener, this is a profound insight. A distant, icy moon is not a static world, but a dynamic system powered by gravitational forces, maintaining chemical and thermal gradients that could, in principle, support life, and offering a glimpse into planetary processes that operate on scales both immense and subtle. Chapter 26. Hydrothermal vents. Earth's analogues in Europa. Beneath Europa's ocean, hydrothermal vents are thought to rise from the rocky seafloor, heated by tidal energy transmitted from the ice-and interior. These vents would release mineral-rich fluids, creating localized hotspots where chemical reactions provide energy and nutrients. On Earth, similar vents host thriving ecosystems of microbes and extremophores, organisms that survive without sunlight, relying solely on chemistry for energy. Webb cannot see these vents directly, but the chemical signatures detected at the surface, fresh sodium chloride, carbon compounds, and hydrogen peroxide concentrated in chaos regions, strongly suggest that vent-like processes are active below. For the listener, picture descending into a dark ocean where plumes of scalding, mineral-laden water emerge from chimneys in the seafloor, surrounded by life adapted to extreme conditions. These chemical gradients create pockets of disequilibrium that organisms can exploit, providing both energy and nutrients, while currents mix the fluids into the surrounding ocean. The surface patterns of salts and carbon reflect these subsurface processes, showing that material rises through fractures, then tidal and chaos terrains, carrying ocean chemistry to the ice above. This continuous exchange is critical for sustaining a chemically dynamic environment over millions of years, maintaining potential habitability. For you, the listener, the idea that a moon 500 million miles away hosts processes analogous to Earth's hydrothermal vents is both thrilling and humbling. Webb's data, but reveals the indirect signs of these vents, allowing scientists to infer ocean dynamics, chemical energy flows, and potential sites of habitability. Europa's ocean, like Earth's deep sea environments, may thus sustain life in ways completely hidden from view, with surface chemistry acting as a readable record of processes occurring miles below, offering a tantalizing glimpse into a world both alien and familiar. Chapter 27. The interplay of ocean and ice. Europa's habitability depends not only on the presence of a subsurface ocean, but on the continuous interaction between that ocean and the overlying ice shell. Webb's observations reveal that salts, carbon compounds, and hydrogen peroxide are concentrated in fractured regions, indicating active transport from the ocean through the ice. For the listener, imagine standing on a frozen plain where every crack and jumbled slab acts as a tiny portal, allowing chemical material to move upward. The ice is not a uniform block. It is a porous, fractured medium, constantly renewed by tidal heating and convection in the ocean below. Crystalline and amorphous ice coexist, showing that the surface is young and chemically dynamic. Crystalline ice forms where molecules have time to organize, while amorphous ice results from rapid freezing or radiation disruption. Their coexistence reflects ongoing processes, including the upward migration of ocean material. This dynamic interface allows energy from surface-generated oxidants to meet reductant tests from the seafloor, creating chemical disequilibrium that could, in principle, sustain microbial life. The alignment of fresh chemical deposits with chaos terrains, ridges, and lenticule demonstrates a regulated system of exchange, rather than random deposition. For scientists, these surface patterns provide critical information about ocean composition, energy flow, and potential habitability, allowing them to infer processes occurring miles below without physically accessing the ocean. For the listener, visualizing Europa as a living system where ocean and ice interact constantly, exchanging energy and materials, transforms a distant, frozen moon into a world alive with chemical activity. Webb's data highlights that this interplay is ongoing, persistent over millions of years, and essential to maintaining a habitable environment beneath miles of ice. Understanding these processes is key for future exploration, guiding Europa Clipper and other missions to target regions with the freshest deposits and highest probability of accessing chemical signatures from the ocean. Chapter 28. Lenticule and convection. Europa's surface is dotted with small, oval features called lenticule, often overlooked but critical for understanding how the ocean communicates with the ice shell. Some are domed, some sunken, and others appear flat, but all are believed to form when warmer, softer ice rises through the colder upper shell. This slow convection allows materials from the ocean to reach the surface, creating chemical anomalies that Webb detects in chaos regions. For the listener, picture a pot of thick porridge, with bubbles slowly rising to the surface, leaving subtle disturbances that solidify once they cool. Each lenticule represents a trace of ocean activity frozen in time, a record of upward convection and chemical transport. Combined with chemical signatures of salts, carbon, and hydrogen peroxide, these features reveal a system in which the surface and ocean are intimately linked. Unlike plumes, which erupt sporadically, convection through lenticule is persistent and widespread, distributing energy and chemicals across large areas. This process refreshes the ice, maintains chemical gradient, and allows for continuous exchange between oxidants generated at the surface and reductant tests from the seafloor. For scientists, lenticule provide critical clues about the pathways of material movement, the intensity of tidal heating, and the dynamics of the ice shell. For the listener, imagining the slow, rhythmic movement of ice helps to conceptualize Europa as a living, breathing system, subtle, patient, and incredibly ancient. The convection that creates lenticule ensures that chemical energy and building blocks for life are continuously cycled, maintaining the habitability of the ocean beneath. Webb's detection of fresh chemical deposits in these regions provides a direct, observable link between the hidden ocean and the ice shell, offering humanity its first glimpse into a world where life's ingredients may be actively circulated in a frozen alien environment. Chapter 29. The hidden heat of Europa's interior. Europa's ocean is not warmed from within by radioactive decay, as on Earth, but by a process far more dramatic: tidal heating. The gravitational pull of Jupiter stretches and flexes the Moon, generating heat in both its rocky mantle and ice shell. This energy keeps the subsurface ocean from freezing solid, doctors convection, and powers chemical reactions essential to habitability. For the listener, imagine bending a metal rod repeatedly. Each flex produces heat, energy, and stress. On a planetary scale, Europa undergoes this process billions of times over eons, producing pockets of warmth beneath the ice that sustain dynamic current. Webb's observations of chemical deposits concentrated in regions like Terra Rio suggest that these tidal effects are not uniform. Some areas receive more heat, promoting upwelling of ocean material through cracks and culae. This dynamic system ensures that salts, carbon compounds, and hydrogen peroxide continually circulate, maintaining chemical gradients that could support microbial ecosystems. The interplay between tidal heating, ocean convection, and ice fracturing creates an environment remarkably similar to Earth's hydrothermal vents, where life thrives in darkness and under extreme pressure. Even without direct evidence of life, the distribution of fresh chemical material on the surface demonstrates that Europa is not a dormant world. It is a living, mechanically active moon with energy flows, chemical pathways, and a constantly renewed surface. For the listener lying back, eyes closed, imagine a hidden ocean alive with movement and energy. Its currents driven by the gravitational heartbeat of a giant planet, silently shaping the chemistry of a moon 500 million miles away. Webb's detection of freshly deposited materials in these regions provides the first confirmation that Europa's ocean is not isolated, but intimately connected to the surface, offering a window into the processes that sustain its habitability. This hidden heat is the engine powering Europa's chemistry, circulation, and dynamic interface, a silent force that maintains a living system under an icy shell. Chapter 30. The role of fractures in chemical transport. The fractures and cracks on Europa's surface are more than geological scars. They are essential conduits for the movement of ocean material to the ice above. Webb's infrared data shows that regions of freshly exposed ice, particularly in chaos terrains and around culae, are enriched with sodium chloride, carbon compounds, and hydrogen peroxide. These chemical signatures indicate that the ocean is actively delivering material to the surface, creating a continuous cycle of replenishment. For the listener, imagine a frozen plain where every crack is a hidden channel, allowing water, salts, and dissolved gases to migrate upward. These fractures vary in size, from narrow fissures to expansive chaos zones, but collectively they form a network that maintains chemical disequilibrium, providing both energy and nutrients to any potential life beneath the ice. Crystalline and amorphous ice coexist along these fractures, revealing that the surface is young and constantly refreshed by ocean upwelling and localized heating. The movement of material along fractures also helps distribute oxidants from the surface into the ocean below, where they can interact with reductant tests from hydrothermal activity, sustaining chemical gradients essential for life. Webb's detection of fresh chemical deposits along these pathways demonstrates that Europa's ocean communicates with its surface in a systematic, ongoing manner. For scientists, mapping these fractures is critical for planning future missions like Europa Clipper, which will target these areas to maximize the chance of sampling chemically rich material. For the listener, visualizing these fractures as invisible highways carrying salt, carbon, and energy helps to conceptualize Europa as a dynamic, living system where the ice above and ocean below are intimately connected. Each fissure, crack, and chaotic zone is a physical manifestation of the moon's internal energy and chemical circulation, a tangible expression of processes operating quietly yet persistently beneath miles of ice. Webb's observations provide the first direct evidence of these pathways, showing that Europa is not a static moon but an active, chemically vibrant world. Chapter 31. The interconnected system of ocean ice and rock Europa's habitability is defined by the intimate connection between its ocean, ice shell, and rocky mantle. Webb's infrared observations reveal that salts, carbon compounds, and hydrogen peroxide are concentrated in fractured, chaotic regions, indicating that material from the ocean below is actively transported to the surface. This dynamic exchange suggests a complex, interconnected system where chemical energy and nutrients circulate continuously. For the listener, imagine standing on a frozen landscape where every crack, ridge, and lenticular acts as a portal connecting the ocean beneath to the ice above. Tidal heating from Jupiter flexes the moon, warming the rocky interior, driving hydrothermal activity and sustaining ocean currents. These processes transport chemical material upward through fractures in porous ice, replenishing the surface with freshly deposited compounds that Webb detects in real time. The coexistence of crystalline and amorphous ice in these regions confirms that the surface is young and actively refreshed, allowing chemical signals from the ocean to remain intact despite the destructive effects of radiation. This interconnected system creates chemical gradients that could sustain microbial life, where oxidants from the surface meet reductant tests from hydrothermal vents below, generating energy in pockets across the ocean. For scientists, understanding these pathways is critical. It informs the selection of target regions for future missions like Europa Clipper, guiding instruments to areas most likely to contain chemically active material. For the listener, visualizing this interplay helps conceptualize Europa as a living world, where the ocean circulates, the ice responds, and the rocky mantle contributes energy, forming a cohesive system that has been operating for billions of years. Webb's data reveals this network indirectly, allowing us to infer not just the composition of the ocean, but the processes that sustain it, highlighting how Europa's chemical, thermal, and geological dynamics are inseparable. This is a moon alive in the broadest sense, where ice, ocean, and rock combine to maintain a dynamic, habitable environment, and where the evidence for life's potential is written into every fracture, chemical deposit, and convection pathway Webb has detected. Chapter 32, Surface Refreshing and Geological Youth. Europa's surface is surprisingly young on a geological scale, with some regions only a few million years old, a fraction of the moon's 4.5 billion year history. Webb's observations of fresh chemical deposits, combined with Juno's microwave data, show that crystalline ice persists alongside amorphous ice, indicating continuous resurfacing. For the listener, imagine walking across fractured ice that appears solid but is constantly shifting, cracking, and freezing under the influence of tidal, heating under the influence of tidal, heating and ocean currents. This refreshing process is crucial. It allows chemical signatures of ocean material, including salts, carbon, and hydrogen peroxide, to remain detectable at the surface. Without this active renewal, radiation from Jupiter would destroy these compounds over geological temescals, erasing the evidence of the moon's dynamic ocean. The combination of ice fracture, lenticular convection, and chaotic terrain movement ensures a steady supply of fresh material to the surface, maintaining chemical gradients that could support life. Webb's data demonstrates that these processes are ongoing and concentrated in specific regions, particularly Terra, where chemical activity is highest. For scientists planning future exploration, understanding which areas are geologically young and chemically active is critical for mission planning, enabling spacecraft like Europa Clipper to target regions most likely to provide insights into ocean composition and habitability. For the listener, envision this as a frozen, slowly breathing world, where the ice above responds to internal heat and ocean currents, continually renewing itself and preserving evidence of subsurface processes. This geological youth allows Europa to maintain a living chemical interface, where energy flows from the surface to the ocean and back, where salts and carbon compounds are replenished, and where the possibility of habitability is continually refreshed. Webb's observations provide humanity with its first detailed glimpse of this dynamic system, revealing Europa not as a static ice ball but as a young, active, and chemically alive world. Chapter 33, the silent chemical exchange beneath Europa's icy crust. A silent but continuous chemical exchange is taking place, linking the ocean, ice linking the ocean, and surface environment. Webb's observations reveal concentrations of sodium chloride, carbon compounds, and hydrogen peroxide precisely aligned with chaotic terrains and anti-CULAE, suggesting active transport from the ocean below. For the listener, imagine a frozen world where miles of ice act as a semi-permeable membrane, allowing salts and reactive compounds to seep upward, carrying with them the fingerprints of ocean chemistry. This movement is subtle, operating over thousands to millions of years, yet it maintains chemical disequilibrium, energy gradients, and a constantly refreshed surface. Crystalline ice alongside amorphous ice indicates repeated cycles of melting and freezing, demonstrating that Europa's surface is dynamic and geologically young. The ongoing transport of chemical material ensures that compounds remain detectable by Webb, even under the destructive bombardment of Jupiter's radiation. This silent exchange provides insight into the potential habitability of the ocean. Oxidants from the surface combine with reductant tests from hydrothermal activity below, producing localized pockets of energy that could, in theory, support microbial life. For scientists, mapping these chemical pathways is critical, guiding future missions to the most active and promising regions. For the listener, envision the moon's hidden ocean as a living system, quietly interacting with the ice above, maintaining a network of chemical activity that has persisted for billions of years, and providing a record of processes essential to habitability. Webb's data allows us to read these subtle signals, transforming Europa from a distant, frozen body into a world alive with chemical communication, a laboratory where energy, matter, and chemistry converge in ways that are both alien and strikingly familiar. Chapter 34. Oceanic convection and energy flow. Europa's subsurface ocean is not static. It circulates, driven by tidal heating, hydrothermal activity, and the interaction with the overlying ice shell. Webb's chemical maps, combined with models of tidal flexing, indicate that currents transport salts, carbon, and oxidants across the ocean, allowing materials from the seafloor to reach the ice above. For the listener, imagine a massive, hidden sea, its currents invisible, quietly stirring energy and chemical compounds across miles of water, shaping the surface chemistry over geological temescals. This convection maintains gradients that could provide energy for life, analogous to hydrothermal vent systems on Earth. The combination of upwelling ocean material and surface-generated oxidants creates a chemically active environment where energy is continuously redistributed, supporting the potential for habitable niches. Webb's detection of concentrated chemical deposits in chaos terrains and anti-CULAE supports this model, showing that the ocean communicates with the surface through fractures and porous ice. The slow, persistent circulation ensures that surface chemistry remains young, observable, and dynamic, offering scientists indirect evidence of processes occurring miles below. For the listener, this hidden ocean is a living engine, continuously circulating energy and matter, a silent heartbeat beneath the frozen shell. It demonstrates that Europa is not merely an inert moon but a complex, interconnected system where ocean currents, ice dynamics, and chemical exchanges combine to maintain a stable, habitable environment. Webb's observations give humanity its first tangible glimpse into these processes, highlighting the intricate balance of energy and chemistry that sustains one of the solar system's most promising habitats for life. Chapter 35. Chaos terrains as conduits. Chaos terrains on Europa are more than visually striking. They are essential pathways for the exchange of ocean material to the surface. Webb's infrared observations reveal that these regions contain fresh deposits of sodium chloride, carbon compounds, and hydrogen peroxide, aligned with fractured ice blocks, tilted slabs, and disrupted terrain. For the listener, imagine walking across a frozen landscape where each broken ice block represents a portal through which chemicals from miles below travel upward. These chaotic zones act as natural conduits, linking the ocean beneath with the surface ice. Crystalline ice, forming in regions where molecules have time to reorganize, sits alongside amorphous ice, formed through rapid freezing or radiation-induced disruption, signaling a continuously refreshed surface. The fresh chemical deposits in these areas indicate that material is moving upward over relatively short geological temescals, remaining intact despite Jupiter's intense radiation. This movement maintains chemical disequilibrium, energy gradients, and nutrient distribution, all essential components for potential life. For scientists, understanding the structure and distribution of chaos terrains is critical for planning future exploration, including Europa Clippers flybees, as these regions are the most promising for sampling ocean-derived material indirectly. For the listener, chaos terrains represent the pulse of Europa, the visible expression of energy and chemical circulation beneath a frozen shell. Each cracked block and disrupted patch records the flow of salts, carbon, and oxidants, showing that the Moon's ocean and ice are not separate systems, but parts of a dynamic, integrated network. Webb's data allows us to read these chemical signatures and infer the processes driving them, giving humanity its first view into the mechanisms that sustain a potentially habitable environment miles beneath the surface. Chaos terrains are the veins of Europa's living system, continuously delivering the building blocks of chemistry and energy from the ocean to the frozen world above. Chapter 36. The signature of hydrogen peroxide. Hydrogen peroxide on Europa plays a critical role in the Moon's chemical ecosystem, acting as an energy carrier for potential life. Webb detected unusually high concentrations in chaos regions, particularly near the equator, where radiation from Jupiter interacts with water ice to generate reactive oxidants. For the listener, picture a frozen surface that absorbs energy from cosmic radiation, converting it into chemical potential that slowly percolates downward through cracks and porous ice. These oxidants combine with salts and carbon compounds transported from the ocean, forming a chemically active interface between ice and water. This chemical disequilibrium is crucial because it represents stored energy that life on Earth exploits for metabolism. Europa's system is unique, while the surface is bombarded by destructive radiation. It simultaneously generates and transports oxidants that could fuel life beneath the ice. The precise alignment of hydrogen peroxide with chaos terrains suggests a controlled process, where chemical energy is delivered to regions most connected to the ocean. For scientists, this discovery is a key indicator of habitability, highlighting where energy is available and where future missions should focus their measurements. For the listener, imagine a frozen world where the energy from radiation is not wasted but harnessed, creating pockets of potential life-sustaining chemistry in an otherwise dark, frozen ocean. Webb's detection of these oxidants, together with salts and carbon compounds, paints a picture of a chemically vibrant moon where energy flows continuously, surfaces are refreshed, and the hidden ocean communicates silently yet persistently with the ice above. Hydrogen peroxide is a signal, a marker of Europa's living chemistry, and a testament to the dynamic processes that maintain a habitable environment beneath miles of ice. Chapter 37. Salts as clues to the ocean below. Sodium chloride and other salts on Europa's surface provide critical evidence about the Moon's hidden ocean and its dynamics. Webb's infrared observations revealed that these salts are concentrated in chaotic regions like Terra, forming patterns that correspond with fractures, lenticulae, and disrupted ice blocks. For the listener, imagine standing on a frozen expanse where crystalline salt deposits glisten atop jagged ice, each crystal a message from an ocean miles below. These deposits are freshly exposed, having been transported upward through fractures and porous ice within geologically short temescals. The presence of salts, rather than more magnesium-rich compounds, suggests localized hydrothermal activity or unique seafloor chemistry influencing the ocean's composition. This active transport ensures that surface chemistry remains young and undetectable despite intense radiation from Jupiter, which would otherwise destroy chemical signatures over time. For scientists, mapping these salts provides insight into where ocean material reaches the surface most efficiently, guiding future missions to regions likely to contain the freshest and most informative samples. For the listener, it is striking to consider that a frozen moon 500 million miles away is constantly supplying the surface with material from its hidden ocean, maintaining chemical gradients and energy flows that, on Earth, would sustain microbial ecosystems. Webb's data allows us to read this system, revealing a dynamic connection between Europa's ocean ice and underlying mantle. Salts are more than mineral deposits, they are fingerprints of chemical activity, evidence of a living system operating beneath a frozen shell for billions of years. Each crystalline patch represents an active conduit of energy and matter, silently narrating a story of chemical circulation, surface refreshing, and potential habitability that we are only beginning to understand. Chapter 38. Carbon compounds and the building blocks of life. Webb's detection of carbon compounds in Europa's chaotic regions marks one of the most significant findings regarding the Moon's potential habitability. Carbon, the backbone of all known life on Earth, appears concentrated alongside salts and hydrogen peroxide in freshly disturbed terrains. For the listener, imagine frozen ice blocks containing molecular fingerprints of material that originated miles below in a hidden ocean. The measured ratios of carbon isotopes, specifically carbon-12 to carbon-13, suggest that these compounds were sourced internally, rather than delivered randomly by cometary impacts or produced by radiation alone on the surface. This finding provides strong evidence that Europa's ocean is chemically active, supplying its surface with material that could serve as the foundation for life. Carbon compounds rise through fractures and lenticulae, interacting with salts and oxidants to form localized pockets of chemical disequilibrium, zones of energy that, on Earth, would be ideal for microbial ecosystems. For scientists, these observations are invaluable. They allow inference of ocean composition, transport pathways, and potential energy sources for habitability, all without physically penetrating miles of ice. For the listener, visualizing carbon compounds embedded in fresh ice deposits provides a tangible link between Europa's hidden ocean and its dynamic surface, highlighting a system where chemistry is continuously cycled and energy flows are maintained. Webb's measurements transform our understanding of Europa from a lifeless, frozen moon into a chemically vibrant world, where the building blocks of life are present, actively transported, and interacting in ways that mirror early Earth conditions. This is not speculation, it is a directly observable chemical system, revealing how salts, carbon, and oxidants combine across fractures and chaotic terrains to sustain a potentially habitable environment beneath the ice. Chapter 39. Chemical disequilibrium and potential habitability. The most compelling aspect of Europa's surface chemistry is the presence of persistent chemical disequilibria, which are critical markers for potential habitability. Webb's infrared data shows that sodium chloride, carbon compounds, and hydrogen peroxide are not distributed randomly. They are concentrated in chaotic regions, lenticulae, and freshly fractured ice, creating a natural system of energy gradients. For the listener, imagine a frozen landscape where pockets of chemical potential form invisible bridges between the surface and the hidden ocean below ocean. These gradients occur because oxidants generated at the surface by Jupiter's intense radiation interact with reductant tests supplied from hydrothermal activity or melting the seafloor. This interplay produces energy flows analogous to those exploited by microbial life on Earth, where chemical disequilibria power metabolism in extreme environments. The continuous transport of materials from the ocean ensures that surface deposits remain fresh, allowing Webb to detect them despite the destructive effects of radiation over time. For scientists, this means that Europa is not only chemically active but also energetically capable of supporting life, providing both the building blocks and the power necessary for metabolism. For the listener, it is remarkable to consider that a moon 500 million miles away operates a natural chemical engine beneath a frozen shell, maintaining a subtle but persistent system that could sustain life for billions of years. This disequilibrium is more than a scientific curiosity. It is evidence that Europa's hidden ocean is dynamic, that energy is flowing, and that the interface between ice and water is chemically productive. Each fresh deposit, every patch of concentrated oxidants or carbon, is a window into the ongoing processes beneath the surface, revealing a moon alive in a chemical sense. Webb's data transforms Europa from a distant, frozen satellite into a laboratory of chemical interactions, demonstrating how salts, carbon, and oxidants combine across fractured ice to maintain a dynamic, habitable system that has persisted for geological eons. Chapter 40, Europa. A living world unveiled. Europa emerges from Webb's observations, not as a static ice ball, but as a living, dynamic system where ocean and rocky interior interact continuously to maintain a chemically active environment. The hidden ocean beneath miles of ice is chemically rich, circulating salts, carbon compounds, and oxidants through convection and fractures, delivering material to the surface in regions of chaos terrain, lentiCulae, and double ridges. Tidal heating from Jupiter's gravitational pull powers the system, warming the ocean, driving hydrothermal activity, and refreshing the ice above. For the listener, imagine standing on a frozen plain where each crack and displaced ice block is a conduit, allowing energy and matter to flow between the ocean and surface. Crystalline and amorphous ice coexist, revealing that the surface is geologically young and continuously renewed, preserving chemical signatures of ongoing processes beneath. The chemical gradients observed, oxidants from radiation interacting with reductant tests from the seafloor, create energy-rich zones analogous to hydrothermal vent ecosystems on Earth, where life thrives without sunlight. Carbon compounds rising to the surface provide the essential building blocks for life, while salts and reactive chemicals demonstrate the ongoing circulation and chemical exchange that sustain this environment. Webb's data, complemented by observations from Juno and models of tidal heating, paint a picture of a moon where energy, chemistry, and geology converge to form a living system, active and dynamic, even under an icy crust. For the listener, Europa is no longer an abstract concept or distant satellite. It is a chemically alive world, a hidden ocean with pathways to the surface, and a laboratory that has operated for billions of years. Its ocean circulates, and its chemical fingerprints whisper the story of a potentially habitable environment waiting to be explored. Europa is now a prime candidate in the search for life beyond Earth, a silent, dynamic, and fascinating world unveiled for humanity to witness. Outro, reflecting on Europa's mysteries. As we close our journey across Europa's frozen landscapes and hidden oceans, take a moment to let the enormity of what Webb has revealed sink in. Miles of ice cover a vast, dynamic ocean, rich with salts, carbon, and oxidants, circulating silently beneath a shell that is continuously refreshed by tidal forces and ocean currents. The chaos terrains, double ridges, and lenticulae are not just geological features. They are pathways, conduits, and markers of a living chemical system that has been operating for billions of years. For the listener, imagine standing on the icy surface, feeling the subtle movement beneath your feet, sensing the hidden energy rising from the ocean below ocean, and realizing that this distant world is alive in ways we are only beginning to understand. Every chemical signature detected by Webb is a whisper from the ocean, a clue to processes that could sustain life, and a reminder that habitability does not always require sunlight or familiar conditions. Europa invites us to imagine, to wonder, and to reflect on the possibilities that exist just beyond our reach. If this journey has sparked your curiosity and wonder, consider liking this video. It helps others discover these hidden corners of our universe, where chemistry, energy, and potential life converge beneath miles of ice. Remember, Europa is not just a moon, it is a laboratory, a window into planetary processes, and perhaps a cradle for life waiting to be explored. Keep imagining, keep dreaming, and let these cosmic revelations guide your thoughts before sleep. In the quiet of the night, as you let your mind drift across frozen oceans, on alien skies, remember that humanity has just begun to read the whispers of Europa, and the story of its hidden life is only unfolding now. Thank you for joining this exploration, and stay tuned for more journeys into the universe before sleep, where distant worlds, unseen oceans, and hidden chemistry await your imagination.